All right. Good evening. Good evening. We'll start. I hope I'm clearly audible and visible. Right. Okay. So we are in day 23 of S2A, and today I'm planning to discuss the central points paper. Sound is okay, right? Okay. So today I'm planning to discuss the central potential paper, right? And in last discussions we have finished the support seminar paper, and after that the western potential paper, and now today my plan is to take central potential paper, right? Central potential one. If you have already tried the questions, right, you can check your answers against the discussion. And if you haven't tried it, if you need to get the paper, I have pinned the link here in the live chat. So go there and get it downloaded, right? Get it downloaded. So we are now like 15 days to the exam, right? And the time goes, and we are spending kind of a high time, right? You are spending a high time in your A-level journey, right? That's a high time in the A-level journey, and the most valuable time period you ever get in your A-levels, right? The most valuable time period you will ever get in your A-levels, right? Simple as that. Simple as that. So it's a very critical and crucial time period goes on, right? So manage your time and manage all three subjects, right? Manage all three subjects accordingly, right? Then without any further ado, we'll go to the discussion, right? Let me share my screen. Right, my screen is visible, right? Okay, it's visible. All right, all good. We'll start. Right, question one. Question one. Among the sets of physical quantities given below, which choice below shows a vector quantity and a scalar quantity? Very straight question. Very straight question. A vector quantity and a scalar quantity. Work and power, both are scalars, no? Right? Check one by one. Work and power, both are scalars. Electric field intensity, right? Now about work and power, both are scalars. Electric field intensity is a vector. Electric potential is a scalar, right? And angular momentum is a vector. Linear momentum is also a vector. Tensile stress is a scalar. Strain is a scalar, right? Intensity of sound, scalar. Intensity level, scalar. Right, then we need a vector and a scalar. It's two. Electric field intensity and electric potential, right? Second one. What is the unnecessary characteristic property of the liquid which is used in a liquid in a glass thermometer? Which is used in a liquid in a glass thermometer, right? High boiling point. High boiling point is a much needed feature if you need to have a higher range, right? Then high expansivity. Yes, higher the expansivity, higher the sensitivity. High expansivity means higher sensitivity. Then low specific heat capacity. Yes, when specific heat capacity is low, the liquid is not going to absorb that much of heat, right? Then not wetting glass, right? If glass is wetting, right? If glass is wetting, what happens is that is not going to what we call rise along a tube. Rise along a tube. If glass is wetting, that is going to spread out, right? When it is spread, we can't take a reading easily using it, right? High density is unnecessary, right? High density is unnecessary. And one such example is mercury, right? Mercury, the most popular one, right? Most popular one. Density doesn't matter. Right? Three. The critical angle of ABC isosceles glass prism is 42. The total deviation of ray of light incident right angles to face AB is, okay. So this is a ray diagram we draw in the theory is even, right? Now, at this point, there is a perpendicular incidence, right? Then no refraction there at this point. At this first interface AB, at the first interface AB, there's no refraction. Then check the angles here, right? If this is the normal, we know these isosceles. If this is isosceles, this is 45. This is also 45. Then if this is 90, this is 45. Then this side becomes, see, this side becomes 45. This side becomes 45. This side becomes 45. This side becomes 45. Right? That is the angle of incidence. Now, angle of critical angle for the surface is 42, whereas the angle of incidence is 45. Then theta is greater than critical angle. That is a total linear reflection. Then it is going to reflect like this with the same angle 45. Then you asked about the deviation. Deviation is the angle between the initial ray and the final ray. Right? Initial ray and the final ray, that is 90. That is 90. Right? 4. The focal lengths used in focal lengths of the lenses used in astronomical telescope are 50 centimeters and 5 centimeters. Right. So we know in any telescope, FO is greater than FE. In a telescope, FO is greater than FE. Right. Then FO must be 50, FE must be 5. The length of focal length 50 centimeters should be used as the objective. That is correct, no? That is correct. When the telescope is at normal adjustment, the angular magnification is 10. When the telescope is normal adjustment, the angular magnification is 10. I think there's a typo there. It should be corrected. No, it's correct, no? It's correct. It's correct. Then angular magnification is asked. For the angular magnification, right? You can find the angular magnification. Then angular magnification equals, we know F4F, you know, right? Then 50 over 5, that is 10. So that is also correct. B is correct. The final image is inverted, yes. Right? Using any telescope or a microscope, right? Always we see inverted images. Then all ABC are true. Right? All ABC are true. 5. If the dimensions of electric current is I, the dimensions of magnetic flux density is. Okay. Now, dimension of current is given. If dimensions of current is given, right, we know F equals BIL. No? If current is given, F equals BIL. Then dimensions of force is MLT minus 2. I need dimensions of B. I is given as I, right? L is L. Then L cancels off. Dimensions of B is M I minus 1 T minus 2. M I minus 1 T minus 2. First one, right? M I minus 1 T minus 2. First one. Right? 6. When a body hits the ground after vertically drops from a height h, 50% of its kinetic energy just before the impact is lost. What is the velocity of the body with which bounces? Okay. When the body hits on the ground, vertically drops from a height h. So we know if an object drops from a height h, velocity at this point, right, after falling a height h is given by root 2 gh. Right, then the velocity is root 2 gh. Right, and kinetic energy is lost by 50%. Now at this point, before collision, say kinetic energy is E1. E1 is half m v squared, that is 2 gh. Right. Now, if this is lost by 50%, E2 should be half of this element. Then half m velocity is asked, right? Just before impact is, what is the velocity of the body? Okay. Then let's say this is u, velocity is u squared, and the given data is E2 is 50% lost. Then E2 is half of E1. For E2, we can use E1 over 2. Half is lost, only half remains. Then half m u squared. E1 is keep this 2 here. E1 is half m 2 gh, right? E1 is half m rho gh. This is half m u square. Then half to m2, half to m cancels, right? This 2 to 2 also cancels. U squared equals gh. That's here u equals root gh. Then u equals root gh. Root gh it's 4. U equals root gh. Right? Then 7. If a body which undergoes a simple harmonic motion, the speed is maximum when the displacement is maximum. The speed is maximum when the displacement is maximum. Wrong, no? Because maximum speed is at center. At center, displacement is minimum. Right? So first one is wrong. First one is wrong. Second one, the magnitude of the acceleration is maximum when speed is maximum. No. Acceleration is maximum at amplitude. Speed is 0 at amplitude. Speed is 0 at amplitude. Then the speed directly proportional to the displacement. Speed directly proportional to the displacement. No. Why? V squared equals omega squared a squared minus x squared. No. Now, if you need speed is omega root. Speed is omega root a squared minus x squared. This is not a directly proportional equation. Right? This is not directly proportional. Wrong. Then 4. The direction of the acceleration is always constant. Direction of the acceleration is always constant. No. Direction of acceleration is towards center. Then when center is passed, it changes. When center is passed, it changes. Last one, the magnitude of the acceleration is always directly proportional to the displacement. That is correct. That is correct because we know general equation of a simple harmonic motion is a equals minus omega squared x, where omega is a constant. Then a is proportional to x always, right? Minus is also constant. No? A is proportional to x. A is proportional to x. That's a normal idea. 8. A body of weight W is placed on a rough horizontal surface. When a force P is applied with an angle theta, the horizontal as shown in the figure, the body is in equilibrium and the frictional force on the body is F. Consider the following statements. Right. And we know from here, one component acts like this, P sin theta. The other component is here, P cos theta. Right. W weight acts. Then a reaction from here acts. Then because of this rightward force impact, friction acts leftwards. Right, this is a force frame, no? That's a force frame. Then F equals P cos theta. Yeah, there are only two horizontal forces, no? Then horizontal equilibrium. Horizontal equilibrium, horizontally rightwards F, horizontally leftwards, only P cos theta. That is correct. That is correct. Then B, the normal reaction on the body from the horizontal surface is W minus P sin theta. No. If you need to find normal reaction, get the vertical equilibrium. Vertical upwards, we have R. Vertical downwards, there are two forces, P sin theta plus W. Then that is not W minus P sin theta, that is actually W plus P sin theta. W plus P sin theta, this is wrong. See, the body is at the state of limiting equilibrium. Right? We can't say, right? That is in equilibrium doesn't mean that is in limiting equilibrium because, right? So we know limiting point is only here. This is the limiting point, limiting friction. And any point up until the limiting point, right? Any point up until the limiting point is also an equilibrium, right? Then we can't say whether it's limiting equilibrium, right? Without any other data given, right? Then only A is correct. It is 1. Only A is correct, right? 9. The end of the thin, light, inelastic string is tied to the ceiling, and the other end is attached to a 40 newtons weight cube. P of material of density 2500. Keeping a beaker below the cube, when it is filled with water of density 1000, gradually up to the level AB, the minimum tension of the string would be, right? So we know, right here, mg acts, upthrust acts, and tension of the string acts as forces, right? So write a vertical equilibrium. Vertically upwards we have u plus t, downwards only mg. Then tension is given by Tension is given by mg minus u. Tension is given by mg minus u. Then mg is known now, it is 40 minus u. U is v rho g. U is v rho g, right? We know m equals v rho. Then for v, we can write m over rho. M is 4. Rho of that given one is 2500, right? M over rho. Then rho density of water is also given 1000 g, right? Then simplify 0 to 0 to 0 to 0 cancels. Then 25 times 4 here, that is 16. Then T equals 40 minus 16. 40 minus 16 is 24 newtons, right? Straightforward, right? That is 24 newtons. 24 newtons, right? Then 10. As shown in the figure, the ball A moves with a velocity u and collides with the ball B, which is at rest on a smooth horizontal surface. Consider the following statements. Statement A. If only the velocity u is along the direction of the line joining the centers of A and B, the force on B by A and the force on A by B are opposite in the direction. Now, we know that force, there is a popular force that is given about. Right? What is that? That force is impulsive force. Right? That is called the impulsive force. Impulsive force is always same. Right? Impulsive force is always same in magnitude and opposite in direction for any kind of a collision. Impulsive force is always same in magnitude and opposite direction. Then there's nothing like the velocities are to the direction to the line joining. No, nothing. For any collision, impulsive forces are equal and opposite because impulsive forces are coming down, breaking down from Newton's second law. Right? So there we have equal and opposite forces only. So A is wrong. As a statement, A is wrong. B. Although the velocity u is acting along any direction before collision, the reduction of momentum of A towards a certain direction is same as momentum gained by B towards the same direction. That is correct. That is correct because that is what we call conservation of linear momentum. That is what we call the conservation of linear momentum. That is what we call the conservation of linear momentum. Right? B is correct. The law of conservation of energy does not apply for the collision. Right? We don't know whether this collision is elastic or inelastic. Right? We don't know whether this collision is elastic or inelastic. Right? If this collision is elastic, kinetic energy can be applied. Right? Conservation of energy can be applied. Right? If there is elastic, right, it can be applied. But if it was inelastic, that is not given. Right? We can't apply. Then, as a statement, as a general statement, we can't say the law of conservation of energy does not apply. We can't say, right? Wrong, because for elastic collisions that is applicable. Then only B can be taken. Only B is correct. Only B is correct. Right? Only B is correct. Right. 11. A current 3.2 amperes flows along a wire of cross-sectional area 1 square millimeter. The electron drift velocity is 2 millimeters per second. If the charge of an electron is 1.6 times 10 minus 19 coulombs, the number of free electrons in a unit volume of the wire is. Right? About drift velocity, we have only one equation in the syllabus. Right? About the drift velocity, we have only one equation in the syllabus. Right? The equation I equals when A. I equals when A. right? I equals NA. Then I is given 3.2, right? And velocity, if velocity is given 2, but that is in millimeters, then 10 to the power minus 3. Area is in millimeters, right? Then 2 millimeters, 2 meters 10 to the power minus 6. Then we need n number of free electrons. Number of free electrons, we need n. E charge of an electron 1.6 10 to the minus 19. Right? Then 1.6 times 2 here, and this 2 also cancels off. 2 cancels. Then only 10 to the power remains here. Minus 3, minus 6, minus 98. 6 means 6 minus 3 and 9. Then 28. Then n equals 10 to the power 28. 10 to the power 28. 5. Right? That's a normal question. 12. From the nucleus of radioactive atom, A, the atomic number is increased by 1 when a beta particle is emitted. That is correct now, because beta is 0 minus 1. Beta is 0 minus 1. Beta is the only particle. Beta is the only particle which can increase atomic number when emitting. Right? Beta is the only particle which can or which cause in increasing atomic number when emitting. Right? So it is increased by 1. That is correct. B, the atomic number is decreased by 1 when a beta plus. What is beta plus? Positron. That is 0 plus 1. Then with this plus 1, it decreases. It is also correct. C, the atomic number is unchanged when gamma is emitted. Correct, because gamma is 0, 0. Right, gamma means 0, 0. Atomic number is unchanged. Then all are true. Right, all ABC are true. Right. Then 13. The cross-sectional area of rubber hose, which is used to water a lawn, is 2.4 square centimeters. There is a shower connected to an end of the hose, and 20 holes of cross-sectional area of each 2 square millimeters are in the shower. The water flows through the hose with the velocity 1.5 and enters the shower. The speed of water flows out through a single hole is right. Then we know continuity equation V1 equals A2 V2, right? Always inflow equals outflow. Continuity equation. The inflow is area 2.4. That is in square centimeters. Then 10 to the minus 4. And V1 is 1.5. Right? Then A2, area of the other side is 2 square millimeters, then 2 times 10 to the minus 6. Right? We need V, and there are such 20 holes. Right? Then this cancels, no? This is 2 times 1.2. 2 times 1.2. Right? And by 20 again we can cancel. By 20, right? If it was 2, that is 0.6, then for 20, right, 0.06. Right, now we do just check the numbers first. Right, numbers are 6 and 15. No? Numbers are 6 and 15 without checking the 10 to the power. Right, the number here is 6 times 15. No? That is 90. Then that is 90. Then we have only one answer with 9 in it. Then it must be 3. It must be 3. Now need to simplify to the last point. Right? Don't simplify to the last point. No need. 14. A circular disk is set to rotate freely about a vertical axis through the center of a horizontal plane by means of a string, which is wound around the circumference. circumference of the disk, and uh, a constant force F is applied tangential to the disk. The graph which best shows the variation of angular velocity with time is okay. Create equation. I always when graphs are given, create equations when you argue. Then to create something for alpha, we know torque equals I alpha. If this force is F and the radius is R, Fr equals I alpha, which means alpha here is Fr over I. Then if you need omega, right, then omega 2 equals, we know, omega 1 plus alpha d, right? Omega 2 is omega 1 is 0, right? Alpha is here, Fr over I t. Then omega equals final equation, right? Fr over I times t, right? Now this is our x-axis. Fr over I is gradient, and this is y, right? Y equals mx. And you have to make sure whether the gradient is a constant or a changing value, because if there is constant, that is a constant gradient. But if there is a changing gradient, then accordingly you have to draw a changing graph. Right now it is constant. No? F is a constant, it's given. R is a constant, radius of disk is a constant, moment of inertia is a constant. Right? Moment of inertia of disk. Then that is y equals mx. Right? Y equals mx. Then 15. The figures A, B, and C show three rods of length L, which moves downwards freely in a uniform horizontal field of flux density V. In the instance shown, the time is t equals 0. When t equals t, if the induced electromotive forces along the ends of the rods are rods in ABC are EA, EB, and EC, which is correct among the relationships. Okay, so we know when a rod travels in linear motion in a magnetic field, right? When a rod travels in linear motion in a magnetic field, induced EMF is given by BLV. Induced EMF is given by BLV, right? There are three conditions to satisfy when applying this equation, when using the equation, right? One is B and V should be perpendicular, right? Then V and rod should be perpendicular, V and rod, right? And finally, magnetic field lines should be intersected. Magnetic field lines should be intersected, right? Now go to first scenario. All three conditions are satisfied. Right? And so it is non-zero here. For B, can you see B and V are perpendicular, but V to rod are not perpendicular, and there's no even a dissolved component we can write, right? Then second condition is not satisfied. Then this becomes 0, right? This becomes 0. And C that is inclined, but we have a component like this. We have a component like this, which is perpendicular. We have a component. Components are always less than the original vector. Right? That is non-zero, but that is less than the original vector. Then the smallest one is EB, that is 0. And then EC, and finally EA. Right? Then EA is the greatest, right? Then EB, no, it's 4. I have to know these equations. Consider the following coplanar systems of forces which pass through the same point. Right. Now about these two, P and P cancels off, but this P remains without cancelling. So that is not an equilibrium. Right? That is not an equilibrium. And about these two, right? These components are going to cancel because they are like root 3p sine 30 each. Right? This is also root 3p sine 30. They cancel off, right? But the vertical components, right? If I write here, are the vertical components, see, vertical components are 2 times root 3p cos 30, no? Right? There are two vectors, no? So I took it as 2 times at once. Then 2 times root 3p cos 30 is root 3 over 2. These two cancels. Then it says 3v, right? It says 3v, which means there is non-zero. Non-zero because upwards now we have 3b. Upwards we have 3b, but downwards there is only p, which means in the system, an unbalanced force remains upwards, right? An unbalanced force remains upwards as 2b, right? Then in the last case, right, again these horizontal ones are equal, no? P sine 30, right? These two are cancelled off, right? Then the vertical ones, if you adapt vertical ones, vertical resultant, let's find the vertical resultant. That's also enough. Then vertical resultant F equals one vector is P cos 30, no? Such 2. One vector is P cos 30, such 2. Right? Then P cos 30 is root 3 over 2. Right? Into 2, these two cancels. That is root 3P. Right? Root 3P. Now this is the upward resultant, root 3P. And in the system, downward one is also root 3P, which means, right, there's no resultant remains in the system. Then for 1 and 2, there were resultants. Then this is only C. Right? Only C. An easier one. 17. A body is projected with an inclination theta to the horizontal with a kinetic energy 100 joules. Right? Projected. Right? With an inclination theta. Right? Say this U. Kinetic energy is 100. Which means now initially kinetic energy equals 100 equals half m u squared, no? Initially half mu squared, and the kinetic energy at the highest point of the path is 25. Highest point is a special point. Right? We know in this point vertical component of velocity becomes 0. At this point. Vertical component becomes 0, but horizontal component of any projectile motion is unchanged. Right? Horizontal component of any projectile motion is unchanged. Then this horizontal component is u cos theta, no? Then at this point also, it is same u cos theta. Then kinetic energy at that point is 25. We can write another equation. Then 25 equals half m. Mass is unchanged, but the velocity is u cos theta. Then u cos theta squared. Divide these two. Then 100 over 25, it is 4. Right? Half m to half m cancels. Then u squared over here, u squared cos squared theta. U squared to u squared cancels off. Then cos squared theta equals 1 over 4. We need cos theta, that is half. Right? Cos theta is half. If cos theta is half, theta is 60. Right? If cos theta is half, theta is 60. Cos theta is half. Right? 18. Consider a situation that a rocket moves towards the opposite direction of the backward thrust of the exhausted gas of burning fuel. And about rockets, one thing that you should know is when fuel is burned, mass decreases. When mass decreases, according to F equals ma, see, when fuel burns, mass increases. Now acceleration is FOM, no? Acceleration is FOM, but as it goes, as it flies, mass decreases. When mass decreases, if F remains unchanged, acceleration increases. Then acceleration increases. So simply, it is moving with an increasing acceleration. It is moving with an increasing acceleration. First one, the acceleration of the rocket increases when the fuel burns with uniform rate, and velocity of the exhausted gas is constant relative to the rocket. Correct, no? Because mass decreases. When mass decreases, it increases. B, the magnitudes of the momentum of exhausted gas and the momentum of rocket are same and they are opposite in direction. Exactly yes. Exactly yes. Why? Linear momentum. That's a conservation of linear momentum. Conservation. Right? That's a conservation of linear momentum. Then C, the increased kinetic energy of the rocket is gained by the chemical energy of fuel. Correct, because now only fuel is burnt to get that energy, right? So that's the chemical energy, right? Otherwise, without burning fuel, there's no any other way of what we call motorizing this, right? Without using uh, fuel, without using fuel here, there's no any other means of powering up this. Then increased kinetic energy is gained by the chemical reaction, correct? Right? By the chemical reaction means chemical energy. It is correct, right? It is correct, right? Then B was also correct, right? The magnitude of the momentum. Yeah, that is the momentum. No, all are correct. Then all ABC are true, right? All ABC are true. 19. The cell of electromotive force E and internal resistance R is connected to an ideal voltmeter. Ideal voltmeter means is an infinite resistance, right? V and resistor R, as shown in the figure, E equals 1.8 volts and R equals 0.6. The reading of the voltmeter is 1.5. Value of resistor is. Right now we know if this is ideal, no current passes through the infinite resistor. Current passes only in this loop. Current passes only in this loop. First of all, we need the current here. Then for that loop, sigma equals sigma ER for that loop. Sigma E is 1.8, right? Sigma ER, I is I, right? R is, there are two resistors, 0.6 and R, right? 0.6 plus R. Now I is here. Current in the circuit is 1.8 over 0.6 plus R, right? Then we need R, no? We need R. We need R. Then if current is known for R, what if we use an equation like delta V equals IR, right? Delta V is given because potentials across the voltmeter and this resistor are same, right? They are same. Then 1.5, I is 1.8 over 0.6 plus 4, right? Times I R, right? Sorry, this is R, right? Then R plus R into R, right? Simplify. Then 15, 18 means by 0.3 we can cancel. 0.3 times 5, 0.3 times 6, right? Then 5 times 0.6 is 3 plus this is this R, this is 5R equals 6R here, right? Then simply R equals 3. Simply R equals 3, right? Then 19, it's 3 ohms, 4. 19 is 3 ohms, it is 4. Right? 20. 20. The figure shows a part of a circuit of a transistor in common emitter configuration. It is used as a signal amplifier. The currents IV and IC are shown in the figure. What is the incorrect among the following statements? Incorrect. Okay. The type of the transistor is NPN. Correct, no? Because if you need to identify this, current flows from P to N. Then this is P, this is N. Then NP means this is also N, NPN. The current in the emitter current is 75. So we know for a transistor, I equals IB plus IC for a bipolar transistor. Then we need I. IB is given 300 microamperes, 300 micro to milli 10 to the minus 3 plus IC 72, right? Then this is 0.3, no? 0.3 plus 72. Then this current is 72.3 milliamperes. 72.3, not 75. 2 is wrong. 2 is wrong. Let's check the others also. The current gain is 240. Current gain, beta. Beta equals IC over IB. No? Then IC is given 72 milli 10 to the minus 3, right? And IB micro 300 10 to the minus 6, right? Then this is 72 times 10 to the 3 over 300, right? 72 times 10 to the 3 over 300. Then these two cancels. Then 720 over 3, that is correct. 240. Right? This is also correct. The base voltage VB equals VB. Correct, because VE is grounded. Because VE is grounded. Right? V is grounded. Then the base voltage VB is VB. Right? VB is VB. Right? Because VB equals VB minus VE if you need to prove. And V is grounded. Then it is VB equals VB. This is given. Then Vin equals IBRB plus VB, correct? Write the cross line of the transistor. Right? Write the cross line. If you write the cross line like this, starting from Vin, right? Crossing RB, then there is IBRB. Crossing RB, right? When crossing RB, IBRB plus crossing the BE junction, VB, right? VB. Then, V in, we were writing cross line for V in, then V in equals, right? There are two parts, IBRB plus this part, VB, right? Then the last one is also correct. This is given. Then answer is answer 2. Right? 75 mAh is 72.3. That is not 75, that is 72.3. Right? That's the difference. Right. Next. #21. In question 21, there's a small typo. Right? I have to correct this x-axis as 70, 140, 210, and 280. Right? Correct the graph. That's a typo. Correct the graph. Right. Then 21. The graph shows the variation of tension on a wire with the extension of it. Consider the following statements. Tension with the extension. Right? Tension with the extension. In the region AB, the wire obeys Hooke's law. Correct? No, because Hooke's law is F equals KE. Right? F proportional to E. Right? It obeys Hooke's law. It obeys Hooke's law. Right? And always when we get a linear graph, which means it obeys Hooke's law. When we get a linear graph, otherwise, if the graph is nonlinear, it does not obey Hooke's law. Right. Then first one is correct. Second one, the Young's modulus of the material is 7 times 10 to the power 8. Young's modulus can be determined to determine Young's modulus, we have to have a stress strain curve like this, a stress strain curve. In a stress strain curve, right? In a stress strain curve like this, gradient gives, right? Gradient is F over A over E over L, no? Right? That is Y. Right? That is Y. Young's modulus again, stress strain curve again with right. Otherwise, we can't get Young's modulus from this Fe. Right. Then see, when T equals 200 newtons, the energy stored in the wire is 2 over 7. Right. Then using this given graph, right? Now these two are two satisfying points. No? These two are two satisfying points. Then to find K, if I use a point from the graph to find K, right? We know F equals K using Hooke's law. F is 70 at that point. I need K is 1 millimeter. 10 to the power minus 3. Right, then K is 70 times 10 to the power 3, no? 7 times 10 to the power 3. Now, extension, when a force 200 is applied, we can use this equation again and find it out. Right, F is 200, because the thing is, 200 is not a point given on the graph. Since that is not a point given on the graph, you have to do some additional working and find it out. Otherwise, we can't guess anything from the 210 given. I need E at 200. Then K is 70, 10 to the power 3, E. Then 10 to the power 2 to 10 to the power 2 cancels off. Then E is coming as 2 over 700. See, E is coming as 2 over 700. If E is known, we know how to write energy. And if E is known, we know how to write energy. Then strain energy is given by half F E. Then half F is 200, E is 2 over 700. 2 over 700. Then 2 cancels. 100 to 100 cancels. It is 2 over 7. 2 over 7. Then 2 over 7 is a correct statement. 2 over 7 is a correct statement. B is a wrong statement. Then only A and C. Right? Only A and C. It's 2, no? Only A and C. Only A and C. Right? All about arguments. Right? 22. Along the plane shown in the figure, the body piece slips down with a constant velocity. Right? If there is a constant velocity, right? My first hint is that is a zero acceleration. No acceleration. Zero acceleration. Right? The graph which shows the variation of work done, W, against the friction with time is. Right. So we know if you check these forces, this is mg. Along this direction, right, the component we have is mg sine theta. Then friction should be opposite, like this. Right? If there is a constant velocity, we know F equals mg sine theta. Constant velocity means no acceleration. Then forces are equal. Now, work done against friction, no? Work done against friction. Any work is given by force into displacement. Work done against friction is done by mg sine theta, right? Work done due to friction or by friction is done by friction, and work against friction is done by mg sine theta, right? Mg sine theta, then force is mg sine theta into displacement s. Right, now time is given, no? Time is given. Convert this into time. We know s equals ut. Let's consider that velocity as u. Then w equals mg sine theta. S is ut. Right, S is ut. Now, from here, right? 1 second. Right, now, from here, see, these are constants. Mg sine theta times u is a constant, and t is my x variable. Then whatever is as a product with x is the gradient. This is y. So it says y equals mx. Only y equals mx curve given here is 1. only y equals mx curve given here is 1, right? So it's always easier when we follow proper methods, right? 23. A wave pulse is allowed to pass up from the lower end, along the heavy rope which is suspended vertically. The graph which shows the variation of speed of wave pulse v with the distance x measured from the lower end is. Okay, so first of all, we know this is given by p equals root t over m. P equals root t over m. But about a suspended weighted string, we know about a suspended weighted string, we know, right? Maximum tension is at the top point. Maximum tension is at the top point because it is holding the entire weight of the string, right? And tension at the last point of the string is 0. Then one is if you think of the starting point, at the last point tension becomes 0 when t is 0 according to the equation, right? When t equals 0 according to the equation, p is 0. Then graph should be started from the origin. Graph should be started from the origin, at the origin. Then to check the variation, we know this tension increases as it goes up, no? Tension increases as it goes up. When tension increases, V increases. It is true, V increases. But tension increases inside the root. Tension is inside the root, right? Tension is inside the root, right? Then inside the root means again that increase value is going to be a root value, right? Increase, that increase is going to be rooted, right? That's a root. Then that is increasing with the decreasing rate, right? That is increasing with the decreasing rate. Only graph with the increasing with the decreasing rate is 5. Only graph with an increment with the decreasing rate is 5, right? So simply, if you get graphs with constant increases, they are linear. If you got graphs with increasing with an increasing rate, they are like this, increasing with increasing rates, and increasing with decreasing rates are like this, right? So that's how those three are. 24. Consider the following statements made about water waves produced in the ripple tank, which is used in the laboratory. Right, water waves in the ripple tank. A. The amplitude of the circular wave fronts made by vibrating point source near the surface of water diminishes when they are propagating. Yes, because for any kind of a wave pulse or a wave, right, it has a damping. Only for the questions only, right, we neglect the energy loss. Otherwise, in reality, there's a non-zero energy loss. For any wave, there's a non-zero energy loss. Right, so therefore, it diminishes. A is correct. Right, B. By moving the vibrating point source along the surface of water of the tank, Doppler effect can be demonstrated. Correct, no? Because right, if this vibrated source is moved, right, what happens is, right, when this is taken to this direction, what happens is, right, according to Doppler's effect, right, in this side, right, towards the velocity, frequency increases. When frequency increases, lambda decreases. To this side, away from the velocity, frequency decreases. So lambda increases. Then we can check this lambda here, right? We can check this lambda here from the ripple tank. Then we'll get something like this. If we draw this, we'll get something like this. Towards this side, lambda increases. Towards the other side, lambda decreases. See, something like this we will get. Then towards this side, lambda is decreased. Towards this side, lambda increases. So Doppler's effect can be demonstrated. Right? Correct. Then C, when the height of water tank is low, by making two sides of different heights, the refraction of waves can be demonstrated. Correct, no? Because we know this dense areas act as rare medium, and shallow areas act as dense medium. Then if a difference in heights can be made, deep and shallow can be made, right? Deep and shallow can be made. This is coming from this. If you don't know, V equals root GH for a liquid, right? For a wave in a liquid, right? V equals root GH. Then other than that, we know NV equals K for a wave, then V is given by N over K, right? V is given by K over N, V is given by K over N, K over N equals root GH, right? See what happens when height increases. See, when height increases, higher the height, now from this side, lesser the N, right? Lesser N means that is rare. Lesser N means rare. Then higher height means deep. Deep areas act as dense. I mean, this should be deep. Deep areas act as rare, right? Deep areas act as rare, and shallow act as dense, right? This is deep. Now, deep act as rare, and shallow act as dense, right? Then if the height is different, then deep and shallow can be made. When deep and shallow is made, refraction can be demonstrated, because in refraction it changes, no, medium changes. Now it is acting like two different media, dense and rare, right? Then B is also correct, C is also correct. All A, B, C are true, right? All A, B, C are true. 25. Right? A beaker is filled with water up to a height h. At the bottom of the beaker, a bright source of light is placed at top. A height L above the surface of water, a rectangular block of glass is placed horizontally. When the eye is kept in the point E, right? Point E, then I is here. Point E, the variation of apparent displacement B of the image of O with L is best represented by, right? L is air, right? No need to do again. We know apparent displacement is always due to, right? 1 minus N2 over N1, apparent displacement is always due to a different medium, right? For the apparent displacement, there should be a different medium. There should be a different medium to observer's medium. Now, as an example, say I'm in air medium and I'm observing something in air medium like this, right? I'm observing something in air medium like this. I don't get any kind of apparent displacement or real depth apparent depth effect, because we both are in the same medium. Right? We both are in the same medium. If both are in the same medium, there's no apparent displacement due to such cases, right? Then this I is kept at air, and this L is also air medium. Then it cannot be changed, because these, now if both mediums are same, see what happens from the equation. 1 minus, right? This is also n, this is also n. It is like T 1 minus 1. D becomes 0. Right? There's no apparent displacement due to air medium. Right? Due to the other different mediums, these two. Right? This water and this glass medium, due to this different medium, right? It occurs. Right? Due to the same medium of the observer's medium, right? Nothing happens. Now you asked to plot D with L, no? Right? Even if L changes, D remains unchanged, because what matters for D is, right? What matters for D here is only this glass and water only. What matters for D is only apparent displacement due to glass and apparent displacement due to water. Right? What matters for D is only apparent displacement due to glass and water only. Right? Then no change. It is 1. No change. It is 1. Right? No change. It is 1. Right. Right. Okay, we are halfway through. Right? We'll do the next 25 questions the next day, right? Any questions from these ones we discussed today? Anything? Is there anything to clarify from the ones we discussed today? Any questions? Or is everything clear enough? If everything is clear enough, we can wind up, right? Now we have discussed 25 MCQs in a quick time, right? Now when it comes to these paper discussions, I'll be kind of moving faster because now these days even like 15 minutes, 10 minutes matters, right? When you study, even 10-15 minutes matter, right? Now from my side also, when I do these discussions, I'm trying to make it short as much as possible, but that doesn't mean that I'm not explaining the questions, but kind of moving faster, especially in these days because of the cruciality of the time these days. Okay, then if no questions, we can wind up, right? We'll do another session for the remaining questions, and I'll be taking other papers also for the discussions, right? Practice those ones, and you can check your answers. And improve confidence. That's the ultimate goal here. Improve confidence, get to know all these types of questions, right? Before you go to the exam, right? Understand all the types of questions, get to know about all the types of questions, and make yourself familiar, comfortable, and improve your confidence about the question, right? Then another 50 MCQs, another 50 MCQ paper that you are going to get at the exam is just another paper you are going to get, right? That will be just another paper to what you have done so far, right? Then that is not going to be a big deal. All right, then again, without further ado, I'm going to wrap up. Then work hard, study hard, and stay safe these days. We'll see you again in the next session. Right? Good night and goodbye. See you.